Hello, everyone. I'm making this lesson to summarize the, the discussion board work that I just graded. And each one of you, almost every one of you, unless you did it perfectly, I have give you feedbacks. And now they're all posted on discussion board. There are some common theme of mistakes. So I would like to indicate to you, and I also want to indicate to you that please, please, please study my lessons. Okay. And, when I grade all of your paper, right, we have more than 30 people in this class. There are always people who are doing the perfect job. So I have to grade your paper with discretion. And those discretions are applicable to every one of you. Okay, so the first question, okay, I have seen people show me work like this. Okay, the student will show me work just like this, and this is very common. So the student will write down work like this. I don't know where you learned this. I think I have never shown you any work like that. Okay, so you substituted by 3. Okay, so someone substituted by 3, and you got 0 over 0. And then on the next line, you're telling me that you're factoring this. Supposedly this is your work, okay? Of course, there are still miscellaneous mistakes. The factoring is done pretty well. I would, praise you for that. And the next step, supposedly, okay. And some people would be missing the limit sign. Okay, that's another mistake. Okay, I will talk about. So some people will show me work like this. In this case, you are substituting by 3 and equals 1. When you show this work, when your reader reads your work, what are you telling the reader? You are telling your reader that the question given is equal to 0 over 0, and it is also equals to 1. You're telling the reader that 0 over 0 is equals to 1. That is a mistake, okay? This is what we call contradictory. You are presenting work that are contradictory to each other, okay? Other mistakes include, okay, they're all indicated in your individual feedback. Some people missing the limit. If you're missing this limit, right? For example, this expression, if you're missing the limit, you don't have the limit sign here, they're not equal. This is wrong. Okay, why it is wrong? Because when you see the left-hand side, the limit definition applies to the left, but not to the right. And the expression on the left is completely has a completely different meaning from the expression on the right. So the consequence of missing that limit is serious. Okay? So in your feedback, I have indicated that this piece, right, the left piece has application, definition of limit applies to it, but on the other one, no. On the right-hand side, the definition of limit does not apply to this expression. This is simply just a function. This is just a function with a domain x is not equals to 3. All right? So they are entirely different. Okay? And this expression with limit notation on the function, we are only interested in the behavior of this function in the small neighborhood of 3. Okay, so that's why if you write something like this, you're going to get marked down. Okay, you're going to get marked down. So in summary, what would be the best way to show work for this question? Okay, to show your work, all you have to do for this question, all you have to show, as I have indicated in the feedback paper, is that remove this piece, you remove that contradiction, and you attach the limit to every single step when variable is present. Every single step where the variable is present, right? The variable is about x approaching 3. So whenever you have x, you still attach the limit. And the last step, right, on the last line, do you need the limit notation? On this step, you do not, because x is no longer available in this expression. So this limit notation is optional, unnecessary. Optional, unnecessary. So you can just simply remove it. If you show work like this, you're perfect. Do we have people show work differently? Well, that's fine. I'm not saying this isn't the only way to show work, but most people use shows just, we have like 1 or 2 people who show work perfectly, but most of you just have issues with missing limit, or especially this mistake. This mistake is so common. I scratch my head. I don't understand why, because I never ever taught this way. I have never ever taught this way. Okay? Stop it. Okay, because you show contradictory results. Okay? The only thing I can think of is that you might have learned it somewhere else. Okay? I don't care where you have learned that. It's a contradictory result. But even if you want to show this, it should be shown this way. Okay? So let me tell you, if you really want to show that, okay, you should show it this way. You should say, okay, put this away. Okay? Suppose you're doing this question, right? You need to put some words in between. You need to say, okay, by direct substitution, we got, well, you don't have to say that, but we got this. Okay, you should not put this equal to that because they're not equal. You cannot do direct substitution. Okay, so by direct substitution, we get this, and the letter 0 over 0 is undefined. Then you say, therefore, we cannot do direct substitution. Okay? But if anything, you do that part, you should add a word like this. You cannot do substitution. And for this question, you don't need to show that. Okay? Because the work you've done later, this work, right? If you've shown this work, you have seen your teacher or your reader only have to see the correct work. We don't need to see the incorrect work. So if you show incorrect work and correct work together, you are showing a contradiction. And if you don't recognize there's a contradiction of, for the work you turn in, right? And there's a limit here, right? There's a limit here. Let me not drop the limit, right? So if you don't recognize the work you turn in show contradictory result in our assessment, that you don't understand what you're doing. That's why you get points taken off. Okay? So we are giving you this question. We're trying to assess if you understand what you're doing. Okay? I hope you understand. A similar question will show up on your test this coming week, week number 2, at the end of week number 2. So I hope I can eradicate this kind of mistake completely. Okay? So that's, if you really want to show this piece of substitution, and then you should have said something, and you should say that you cannot do that. You cannot do that. Okay? So by showing that this way, you will surely get points off. I hope I get that information across to you. Okay? And also, once again, I want to emphasize, I suspect, I don't know why you guys don't work like this. I have never taught this way. I have never, ever taught this way. Okay? Number 2, okay, on this question, some people use L'Hopital method. Okay, some people use L'Hopital method. And there's one person use L'Hopital method on this work. I did not take all the points off. But next time on the test number 1 that you're going to see next week, if you use the L'Hopital method, you are going to get 0. Okay, you are going to get 0 for this question. Number 1, we have not taught you how to do derivative. Number 2, we have not taught L'Hopital. Okay, L'Hopital will be taught later. So if you show L'Hopital method without a sufficient explanation, you're not going to get any credit. We're just asking you to do elementary method. Okay? But anyway, so I hope that's clear to you, because you are going to do a test number 1 at end of week number 2 on Thursday. Okay? Now, that's the first question. Second question. On the second question, we have similar issues. What are those similar issues? Okay, number 1, I saw people copy number 4, a negative 4 as a positive 4. Okay, that's a mistake. If you make copy errors like that, and you are bound to lose points. Okay, you're bound to lose points. Number 2 is how to show work. Once again, is that you should not drop the limit. If you drop the limit in the process, you will lose points. All right? So this is one version, a preferred version of how to show work. You show conjugate. I hope you guys now you can look at your classmates' work, graded work, and they're available. And this is a positive here. So this is a conjugate. If you drop that limit, you're going to lose a point. Okay? Because as we mentioned, expression with or without limit, they mean totally different things. And the other thing is, when you show your work, please just take your time. And you have enough time to organize your work well enough. So why rushing it? Okay, I really could feel for some of you guys' work, you're done in a rush. You sometimes you use arrow. If you use arrow where an equal sign is more qualified, you are going to lose points. Okay, because there's always someone in the classroom who have done correctly. And I need to make a distinction for that student who have done correctly. So this next step, okay, I'm typing it because I want it to be absolutely clear to you, okay? Even though writing it down will take me much less time, okay? So this will be how you show work, and some people missing the parentheses. If you miss the parentheses, that's another mistake. For example, if you miss the parentheses here, that's a mistake. I see people missing this, missing parentheses like that. That's a mistake. Okay. And these kind of mistakes you can easily check on your AI. Okay, you can use your AI tutor to check your work, right? Especially for discussion board work like this, right? There's no lockdown browser. There's no, and if you study my lessons, everyone should get perfect points. Okay, I hope you guys understand what I'm saying. Okay. So you can see I'm somewhat disappointed in the work that you have shown. Okay, you should show your best work if you're serious about your grades. Okay. Anyway, you can do better. And now this piece here is minus 16, 26, sorry, minus 16. And then you factor the top. And you factor the top, x minus 4, multiply x plus 4. Okay? We have students make this mistake. They got x squared plus 16, right? So I saw people make mistake like this. I just hope that this is not as common, right? So some people got x squared plus 16, and what is worse, this student tells me, and they got x plus 16, and this student tell me, and this is going to be x plus 4 times x plus 4. That's terrible. You're taking calculus class. How could you make such a mistake? Right? This kind of mistake is totally unforgivable. Unforgivable. Okay? All right. To make you feel better, of course, I've seen this kind of mistake in four-year colleges. Therefore, so just don't make this kind of mistake. And these kind of mistakes can be completely checked easily by AI tutor. And so what is x plus 4 times x plus 4? That's x plus 4 squared. It equals to x squared plus 8x plus 16. So you can see why that's a mistake. I don't want to see this mistake again, guys. Okay. Next step, because x approaching negative 4, x is not equal to negative 4. Therefore, x plus 4 and x plus 4 are reduced. And this parentheses and this parentheses can be removed. And then we can do direct substitution, because now when we do direct substitution, we no longer have zero denominator. So here, x will be replaced by negative 4. This parentheses about negative 4 is necessary, and this x is replaced by negative 4. So of course, next you're gonna get a negative 8 over 10, right? Negative 4 squared is 16. 16 plus 9 is 25. Root 25 is a 5, so it's a 5 plus 5. 5 plus 5 is a 10. So in the end, you get a negative 4/5. This is as much of a calculation goes. This is the amount of calculation you need to do. Of course, you don't need a calculator. Okay, don't need a calculator. We mainly are checking you. We are checking on you. You're not missing the limit. You should work properly. Places that you should have limit, you should have a limit. Places you don't need limit, you don't have a limit. And the sign, when apply. When you start with the limit sign, you continue to use the limit sign until you no longer need it. Okay. The last question here, I try to keep it short. The last question here is we want to see that you know how to use one-sided limit. Okay, that's it. And people, you use all these words, left x greater than 2, less than 2, all of that. You don't need to. You just have to use the right notation. The notation has implied all those meanings you try to say, right? For example, here, all you have to do, you just factor the top, right? So when you factor the top, you got x minus 2 times x plus 3, and the two of them are equal, right? X approaching 2. And some people will continue to say, they will say this, or say that, oh, this is equal to equals to that. They put plus. And there's a mistake right there. We don't know if this limit is equal to the limit from right. So, and that equal sign indicated, you're telling the reader by putting this equal sign here, this equal sign, you're telling the reader the limit from the right equals the limit we're looking for. And from the conclusion, you guys know the conclusion, right? For this question, the limit does not exist. And you're telling the reader limit from right equals to a limit does not exist. And that's a contradiction right there, okay? So how do you express it? Remove this equal, start a new line. You are assessing limit from right. You are assessing limit from right, okay? And because x is greater than 2, all right, x, you have a 2 to the power, you have a little plus sign above 2, it implies, right? So this condition implies two things. Implies that x is approaching 2 and x is larger than 2. So you don't need to say those words. You don't need to say those words. So this notation implies x is approaching 2 and greater than 2. So you can just remove these words. It's all implied in the notation. So when x is approaching 2 from larger than 2, the absolute value of x minus 2 is the same, right? Yes, some of you wrote down that absolute value of x minus 2. This is not entirely necessary, but if you write it down, it's not a mistake. It's okay. It helps you. If it does, you can put it down, but put it down on the side. Okay, so you guys really need to learn to show your work. For that reason, you must watch the recorded lesson. Okay, so x minus 2, when x minus 2 is positive or 0, right, greater than or equal to 0, then you get, the absolute value of x minus 2 is the same as x minus 2. Otherwise, if it's negative, so if x minus 2 is negative, you don't need to have this piece, but if this piece helps you, that's okay. You can put it on the side. So this will be x greater than or equals to 2, and this will be x less than 2. So what we are using here is the top piece, when x is greater than or equal to 2. And now x cannot be 2, by the way, because the domain of this function requires, right, x cannot be 2. But this x cannot be 2 is implied in the definition of limit, okay? X cannot be 2 is implied in the definition of limit. Because in the definition of limit, it says x is approaching 2 and x in the function is defined near a, except possibly at a. So it may not be defined at 2. Okay, so study the definition of limit. Okay. So let me write down here the definition of limit. Okay, definition of limit, which is we write it as x approaching a. Okay, f of x. The requirement says f is defined near a. Okay, and also says in the parentheses except possibly at a. So whether the function is defined at a or not doesn't matter. We can always consider and observe the behavior of the function in the neighborhood of a. We don't really care what the value of the function at a, whether the function is defined at a. So in our case, function is not defined at 2. Okay, so x cannot be 2. That was dictated by the domain. Okay, so when we consider limit from right, so we've done the factoring. Because x cannot be 2, so x minus 2 cannot be 0, so the numerator and denominator will be reduced. So we only have x plus 3, right? And then direct substitution. So we get 2 plus 3 equals to 5. So limit from right is equals to 5. So if you put the equal sign here, like if you put an equal sign there, how will that be read? This will be read that, limit from right is 5, and that is equal to the limit at 2, right? So that will be a mistake. You must remove this equal sign. And then you're going to do limit from left, right? Limit from left. So this will be a negative sign, right? But in that case, you would substitute the denominator of absolute value of x minus 2 when x is less than 2. X is less than 2 is implied in this notation. Okay, and that equals to negative of x minus 2. So x minus 2, we drop the absolute value sign, we put a negative sign there. So now we got limit. Now it is x minus 2 and x minus 2 reduced, so we just have negative of x plus 1. So we got negative of x minus 1, x plus 1, sorry. Okay, so that's how we got negative 2 plus 3 equals to negative 5, right? To show work, this is how you show work. And to summarize, you would say limit from left is not equals to limit from right is not equal to the limit from left. They're not the same, and therefore you say this limit does not exist. How much work you need to show? Just this much. Just this much. Do you have to show this piece? I'm sorry? Do you need to show this letter piece? You don't have to. In the entire process, we are assessing you. If you understand the limit notation. And there's another theorem where we are assessing you. Of course, you understand, right? If limit exists, if this limit exists, right, we're applying this theorem. If this equals to L, and that implies that the limit from left equals to limit from right, and they're all equal to L. So this theorem, this question itself, we are assessing you. Can you use this notation? Do you know how to use this notation? And we're applying this theorem. Okay, so using the notation properly is part of the assessment. Okay, I hope I have made myself clear, and I hope this lesson is short enough, and I will see how much time it is. I think it should be less than 30 minutes. Thank you for watching. And once again, please study and follow my recorded lessons. Okay, study my lessons, follow the steps of my, recorded lessons. And if you do that, you will find this course is super easy. Otherwise, if you don't carefully consider what's being assessed, you don't study the lessons, and you will be sorry. Thank you for watching. Have a great week.